Rocky hills, slides, and cliffs are one of the most unusual landscape communities in the northern forest. They are often places with steep or vertical slopes where the soil is very shallow or non-existent. This landscape community is defined by the lack of soil of any significant depth, therefore lacking organic matter or fine mineral particles in the root zone of plants. The biological community found in these areas has adapted to extreme changes in environmental conditions, including rapid fluctuations of moisture and surface temperature, and the lack of available nutrients within the root zone. Tall vegetation like trees are unlikely to grow here due to the difficulty of anchoring a root system in solid rock. Trees are only found in places where pockets of soils have accumulated in cracks and depressions, providing limited nutrients and moisture. Trees have a long life and a long life cycle. Since rocky hills, slides, and cliffs are subject to extreme climatic events and wildfire, trees may not be durable enough to form a persistent forest community on these extreme rocky surfaces. These mostly vertical areas are termed open, or in the colloquial, barren, but they may be far from devoid of biological activity. Plants that do grow in this landscape are able to accommodate the environmental conditions, often with special adaptations. As an example, lichens or algae that can fix nitrogen for nutrition from the air and can rapidly take up rainfall often survive on the rock faces and are the colonizers who, over time, produce the limited soils other plants depend on. The set of plants that colonize and persist in these areas is often very different than in the surrounding forest, so these areas lend diversity to the landscape and are often considered to be far richer than surrounding communities. Rocky hills, slides, and cliffs sometimes overlap with our Northern Forest Atlas alpine and barrens landscape communities. Topographic position often determines which community classification best fits the plant communities found in any particular landscape. Topographic position also influences ambient air temperature, surface and subsurface water flow, and is often correlated with the chemistry of bedrock. Bedrock at lower elevations is more likely to be calcium-rich. These rugged landscapes often have the best vistas or viewpoints and are attractive to humans. Cliff-dwelling birds such as ravens and peregrine falcons like them as nesting sites for the same reason. Unfortunately, humans often trample sensitive plant communities found at these rocky viewpoints. Geologic processes have determined the form of these communities. At the end of glaciation, approximately 12,000 years ago, these areas were left bare of fine surface mineral material by glacial scouring. The tremendous pressure of thousands of feet of ice and water pressure cleaned and scored these rocky slopes, leaving distinctive smooth and worn surfaces. Because of their topographic position on hilltops, or because of the steepness of slides or cliffs, conditions have prevented the accumulation of fine mineral particles and organic material. Microtopography patterns within these rocky landscape communities, such as fissures, cracks, or depressions, may provide areas where soil and water can accumulate and allow vegetation patterns to develop in response to these more hospitable pockets. Frost action is often a prominent process. Where water accumulates in rock cracks, the freeze-thaw action can lead to more rapid weathering of the bedrock. In some cases, slabs of bedrock and large rocks or boulders are peeled off a cliff face, leading to the accumulation of talus at the base of a cliff. When this process occurs after glaciation, it can lead to accumulations of 10 or more feet of rock debris without embedded fine mineral particles. This process may still be ongoing. It is difficult for trees to grow on these rubble surfaces, or for these surfaces to be grown over, allowing the cracks to persist. These talus communities may have unique biologic components or other interesting features such as ice caves and underground rivers. Another frequent feature in slides and cliffs is penetration by a stream or surface water flow, leading to a different microhabitat, like a waterfall and plunge pool. The variation in these plant communities may lead to smaller microhabitats called slab glades, tall herb glades, oak, hickory, or hornbeam glades, all dominated by shrub trees, grasses, small shrubs, ferns, mosses, and lichens. The same trees that are found in the surrounding forest may creep in along the edges, but their presence is dynamic, subject to senescence, the ebb and flow as climate changes or catastrophic events take their toll. Because they are open and often dramatic, these rocky hills, slides, and cliffs are one of the more visible of northern forest landscapes, and surprisingly, often one of the more biologically rich.